Hello friends, today in this lecture we are going to learn about the fifth assumption of the regression, that is there should be no correlation between independent variables. That means there should not be any multicollinearity among the independent variables. Whatever independent variables you are taking, there should be no correlation among themselves. Because if there is a correlation among themselves, it means that we are studying the same variable twice. So I've already explained about the multicollinearity in the previous videos. So let me explain it again with the help of the same example. In the previous example, I want to see the impact of high blood pressure, high cholesterol, smoking, age, family history, diabetes, obesity and alcohol on the heart disease. So that means in this heart disease is your dependent variable which is dependent on these independent variables. So high blood pressure, high cholesterol, smoking, age, family history, diabetes, obesity and alcohols are the independent variables. So if we are finding out the impact of these independent variables on heart disease, so these independent variables should not be correlated among themselves. If these independent variables are correlated, then the results that we are going to get will be biased. So now in this example, you can see that high blood pressure and smoking are interrelated to each other. Similarly, high blood pressure and obesity are also interrelated to each other. That means if the smoking increases, the blood pressure also increases. As we all know that carbon monoxide from the cigarette reduces the amount of oxygen that your blood can carry and which increases the blood pressure. And similarly, if a person is obese, he will also be having the high blood pressure. So they are interrelated to each other. Now, I have made a correlation table where you can see the correlation among the independent variables. Now you can see over here, the smoking and high blood pressure are very highly correlated with the value of 0.89. Similarly, high blood pressure and obesity are highly correlated, that is 0.85. So that means we can say that there is a multicollinearity among the independent variables, which is not a good sign, or you can say your model is not a good model. So now let us test these multicollinearity in the R studio. Now first of all, let me tell you that what is the impact of these multicollinearity. We can say that multicollinearity can produce estimates of regression coefficient that are not significantly, or you can say statistically significant. We can say that it is just like that we are counting the same variable two times. So it becomes difficult to say that which variable is really influencing the dependent variable. As in our example, we have seen that smoking and high blood pressure are interrelated. So if I want to see the impact on heart attack or heart disease, so we are not able to predict whether smoking is impacting the heart disease or the high blood pressure is impacting the heart disease. Similarly, whether obesity is impacting the heart disease or the high blood pressure is impacting the heart disease. So whenever there is high correlation among the two independent variables, we can say that there is a multicollinearity. There are two options by which we can find out whether there is a multicollinearity among the independent variables or not. So the first option is we can check with the help of correlation table. As I have just told you how to check it with the help of correlation table. And second method by which we can check is by variance inflation factor. Variance inflation factor is commonly known as VIF. And the formula for calculating variance inflation factor, that means I can say VIF is equals to 1 divided by 1 minus R square. So with the help of this formula, we can calculate the VIF. Now there are certain assumptions in the VIF. It says that if the value of VIF comes to be 1, it indicates that there is no correlation between explanatory variables and any other explanatory variables. That means there is no correlation among the independent variables. But if the value is between 1 and 5, it indicates that there is a moderate correlation between the independent variables, but there is often not severe enough to require alteration. That means till the value of 5, we don't have to worry. But if the value of VIF is more than 5, it indicates that there is severe correlation among the independent variables. Now, if this is the case, we can say that the coefficient estimates and the p-value in the regression output are unreliable. That means whether the value, that means all the independent variables are showing the significant output, but still we can say that they are not showing us the reliable output because the independent variables are correlated. So now the question arises, if there is correlation among the independent variables, what is the solution? Now, if you find that there is high correlation among the independent variables, so we have to remove those independent variables. Suppose in this example, the example that I have taken, if high blood pressure and smoking are having the high correlation, so first step is I am going to calculate VIF of high blood pressure, then VIF of smoking. If VIF of high blood pressure is more than VIF of smoking, then I'll remove the high blood pressure from the model. And if the VIF of smoking is more than VIF of high blood pressure, then I'm going to remove the smoking as an independent variable from the model. Now let's understand how we are going to do it. First of all, before doing it in R, let me take you to the Excel sheet. So now this is the Excel sheet. Now in this, I have independent variables of import, USD INR, export and FDI, and my dependent variable is inflation rate. So I want to see the impact of import, USD INR, export and FDI on inflation rate. So the first step is to create a model, and for that we need the package LM test. So first of all, let me create the model. So model underscore regression is equals to ln inflation rate. Now you have to put the tilde sign and I have to take all the variables. First variable is import plus exports plus USD INR plus FDI. So now my model is created. Now let's make a summary. Summary model underscore rig. Now this is the summary. Now from the summary you can see that imports, export, USD INR are significantly impacting my dependent variable inflation rate, but FDI is not significant. So FDI is not significantly impacting the inflation rate. But if you are going to see these independent variables, import and exports are highly correlated to each other. So since export and import are highly correlated to each other, so that means I can say that whatever this regression output is there, this is not showing me the true picture. Although they are significant, but since there is a multicollinearity among export and import, they are not statistically significant. So that means I can say I have to remove either import or export. So before removing export and import, let's see whether they are correlated among themselves or not. That we can do with the help of correlation table. So let us find out. So command is cor. Since we have more than 2 variables, so I'll be using the command data.frame and in bracket imports, comma exports, comma USD INR, comma FDI. Now you can see the results. Import and exports are highly correlated. The value is 0.998. USD and import is 0.167, FDI and imports is 0.020, exports and USD INR is 0.16, exports and FDI is 0.24, USD INR and FDI is 0.26. So you can see that only export and imports are highly correlated, that is 0.99. Now the question arises, how you will say that they are highly correlated or not. Whenever you are finding the value of correlation is above 0.8, we can say that the variables are highly correlated. Now in this we have found out that exports and imports are highly correlated among themselves. So we have to remove either exports or import, otherwise our result will be bias. So next method is by VIF. Now before doing this VIF in R, let me take you to Excel and just see how we are going to do it. Now as we know that this term is my dependent variable, so I don't have to touch this. I have to see whether export, import, USD INR and FDI are correlated among themselves or not, and we are now going to find out whether they are correlated among themselves with the help of VIF. Now whenever we are finding the VIF says that first of all I have to take FDI, I have to put regression 4 times over here. First time I'll take FDI as a dependent variable and import USD INR and export as your independent variables. Secondly, I'll take export as a dependent variable and FDI, USD INR and import as an independent variable. So what we have to do, we have to take all these independent variables one by one as independent variables and other to be the independent variables. So let me solve it. So data analysis, regression. Okay. Now my dependent variable, I am taking FDI as a dependent variable. So FDI is my dependent variable. And my independent variables will be import USD INR and export. I have label confidence and I want the output range to be here and okay. Now this is my summaries output. So first of all I have done for FDI, because I have taken FDI as a dependent variable, so I can say FDI and over here I am writing R square because we need R square only. Now for FDI R square is 0.074887. So now in the next step I am going to take exports as my dependent variable. So let me okay. Now my export will be the dependent variable and import USD INR and FDI will be the independent variable. So let's say data analysis, regression, everything remains same and okay. Now R square will be 0.99. Now next I'll take the USD INR to be the dependent variable. So let me cut it from here and paste it here. Now my USD INR will be the dependent variable and import FDI and exports will be the independent variable. So again data analysis, regression. Now everything remains same because in the E column I have already taken the dependent variable and independent variables are from B to D, from B to D. So I want the output again over here, so it's okay. Now regression summary is there, my R square is 0.09. Now last, I am going to take imports as an dependent variable. Now let me put import over here. Now import is my dependent variable and FD exports and USD will be the independent variable. So again, regression, data analysis, everything remains same. It's okay. I want to rewrite the result over here. My R square is 0.99. Okay, so these are my R square. Now let's calculate VIF. The formula for VIF is 1 divided by 1 minus R raised to power 2. So let's do it. Equals to 1 divided by 1 minus, this is your R square, and your answer is 1.108. So let me drag it. So this is my answer. VIF for FDI is 1 point something, export is 437.45, USD INR is 1.105, import is 437.26. As we have already studied that if the value of 1, that means if the value of VIF is 1, we can say there is no correlation, or if the value is between 1 to 5, we can say the answer is moderate correlation. But if the value of VIF is more than 5, that means there is severe correlation. Now over here we can find that exports and imports VIF is 437 in both the cases. One is 437.45, another is 437.26. That means value is more than 5. We can say there is a severe correlation among the exports and imports. Now let's find out the same VIF with the help of R. Now for calculating the VIF, we have different packages that we have to library over here. So the first package is car. Second package is far away. Third package that you can install is VIF. So I am going to do it with the help of car and far away. So let me library the package car. Okay. Now the command is VIF and your model. Our model is model_rig. Now you can see that import is having a VIF of 437.26, export 437.45, USD INR is 1.05 and FDI is 1.08, and the same result we get it with the help of regression. Now you can see over here the results are same. For FDI is 1.08, FDI is 1.08, export is 437.45, export is 437.45, import is 437.26, and your USD INR is 1.10. USD INR is 1.10. So that means now export and imports are having the high correlation. So we have to drop any one of it. Either you can drop export or import, and then you have to run the regression equation again. Now the next I'm going to show you that how we are going to calculate VIF if we are installing the, or you can say library the package far away. So let's library the package far away. Now the command is far away VIF and your model. So model is model_rig. Now you can see that again the same result. So it's up to you whether you want to calculate VIF with the package of car or with the package of far away. So in this way we can find out the multicollinearity among the independent variables. In the next video, I am going to show you how we are going to test whether there is autocorrelation among the residuals or not. Thank you.